So second verse. Yeah, apologies for this. I'm just sending a link to a student. Um, so an angle is a measure of a turn from a fixed point. Angles of any shape are measured in degrees. A complete turn. One sec. A complete turn. A complete turn is 360, so a right angle is 90 degrees as shown below. There are different sorts of angle: acute, obtuse, and reflex. An acute angle is less than 90 degrees. An obtuse angle is greater than 90 and less than 180 degrees. And a reflex angle is greater than 180 degrees. Well, when identifying angles, which are acute angles, again, we said that these are less than 90 degrees. So this is one, and this is one, as these are acute and less than 90 degrees. So what is an obtuse angle? Greater than 90 but less than 180. So this is one, and that's it. As they're lower than 180 but greater than 90. And what is a reflex angle? The remaining, so these are greater than 180 but less than 360. We use a protractor to measure angles. This is shown in the diagram below. So what is the angle measured here? So the angle measured here is going to be, as we know, this is an acute angle, less than 90 degrees. We look at this number, and this is 35 degrees. It's on the 5 mark. So this is an obtuse angle it tells us here. So we look at the bigger number, which is greater than 90, and that is 140 it is on at the moment. So compass directions, we also use angles to show directions. This is shown below with N for north, E for east, and NE for northeast, etc. The angle turns. Note that Note that a full turn is 360 degrees, so half turn is 90 degrees, being 180 degrees, and a quarter turn is 90 degrees, which is the right angle. If you move from east to northeast in an anti-clockwise direction, you move through half of 90 degrees, which is 45 degrees. So east to northeast is here. That's half of 90 degrees, which is 45 degrees. So what angle do you turn through if you turn anti-clockwise from facing north to southwest? So north is here, southwest is there, anti-clockwise is this way. So it is B. You want to work out the angle of the degrees of B. So this is 90 degrees, and this is half of 90 degrees, so it'd be 90 add 45, which is 135 degrees. South to southwest, anti-clockwise is this, so we want to work out again what this is, and if we do this, that is 180 degrees from south to north. This is another 90 degrees, so that makes it 90 plus 180, which is 270. And then this is half of 90, which is 45, so 270 add 45, which is 315 degrees Celsius. Not Celsius, sorry. Northeast to southeast, again anti-clockwise, so northeast to southeast will be from here all the way to here. So if I draw a line just to make it clearer, it would be from here all the way to there. So that is again here to here is 180 degrees, and then here to southwest to southeast is 90 degrees. So 180 at 90 equals 270 degrees, guys. So the answer would be 270 degrees. So measures of central tendency. Mean, median, and mode are all different ways of describing the average for a set of data. To find the mean, you add up all the numbers and divide by the number of numbers. Sorry, apologies, guys. Sorry, guys, just give me 2 seconds, as I think we might have. Yep, so apologies, but that first, I think 5 or 10 minutes of teaching was yesterday's session, so we will start today's session again. And today we are learning about areas and perimeters of rectangles. So you have already met the concept of area and perimeter, but we'll start with a recap looking at rectangles. Here is a football pitch. It has the dimensions of 90 meters by 45 meters. What is the area and perimeter of the pitch? So to work out the area, you multiply the height times the width, or the length times the width, sorry. So it would be 4,050 meters squared. And to work out the perimeter, you add it twice. So you add as 90 would be this, and 90 would also be this, and 45 would be this and this. So I'll draw a line. So 45, 45, 45. So you would add them all together, and it would equal 270 meters, guys. Um, so let me just erase that. Yeah, so it's easy to confuse the two concepts of area and perimeter, but note the units area in square units, while the perimeter is in just units. The formula for area and perimeter of a rectangle of side length A and B is given below. So area would be A times B and perimeter would be 2A times 2A add 2B, sorry, not times 2B. You need to be familiar with both these formula and know them by heart. The legal dimensions for a football pitch in the Premier League are between 90 meters and 120 meters, and the width is between 45 and 90 meters. What is the maximum possible area and perimeter? So the maximum possible area and perimeter would be 120 and 90. Sorry, 1 second. 1 second. Sorry. So the maximum length again would be 120 times 90, which would be 10,800 meters squared for the area. And for the perimeter, we would do 2 times 120, which is 240, and 2 times 90, which is 180, and we would add 240 and 180, which would become 420 meters. What is the minimum possible area and perimeter? So this would be 90 times 45 for the area, which is, if we check here, 90 times 45, which is 4,015 meters squared for the area, and for the perimeter, it would be 90 add 45 multiplied by 2, which would equal to 270 meters. So that would be the answer. Why, why do you think that these are the current rules? So I guess that they are the current rules because of that the football pitch requires to be that size. and it is a professional sport, so these are the length and rules. Areas of triangles. So here is an area with base length 10 and a perpendicular height 15 centimeters. We can calculate this area as half times 10 times 15, which equals 75 centimeters squared. So this, in fact, this is in fact half of the area of the rectangle of dimension 10 centimeters and 15 centimeters. See the dotted line shown. So the formula for the area of a triangle with a base length A and a perpendicular height H is half times B times H, or half BH, half base times height. So what is the area of the shape here shown below? So the area of the shape here shown below would be half times 3.5 times 2. So it would be 0.5 times 3.5 times 2, which equals 3.5 anyways. So the answer would be 3.5 centimeters squared. So complete the table opposite. Note that is not to scale. So the perpendicular, so here the height is 12 centimeters, as it's telling us 12 millimeters, sorry, 12 millimeters. So the area would be half times 15 times 12. So if we work that out, that is half 10 times 12, which equals 90. So the answer would be 90 millimeters squared. So the answer is 90. The second one, the base is 6 and the height is 4. So this would be half times 6 times 4, which is 12. Anyways. And the third one would be, so the whole base, so it gives us the area which is half B, take it, which equals 22 cm squared. So if we know that the answer is 22 cm squared, and it tells us that the full base is 11 centimeters squared, which would be, I think this might be 4 if I'm right. No, because that, so to work this out, we would do millimeters. Yeah, so if that is 11, so it is half times base, which is 11, times h equals 22. So all we need to do now is do half times 11, which is 8, eight, divided by so h equals 4. It should equal to 4. So the base is 11 and the height is 4. Let's solve this out. And then for the final one, the base is 6, the height is 7, So we would do half times 6 times 9, which is, it should be 21 plus 4. If you guys have any questions, just let me know, please, if you don't understand anything. So, as you can see there, the answer is 12, 20 per second. The answer is 6, 4, and 12 that I put there. For the third one, the answer is, let me think what the answer is. 11 and 1. It shouldn't be 1. This is wrong, guys. It is 4 indeed. The answer is 4 here, not 1. And then the last one is 7 and 21. Varying planets of the circle. You will be familiar with circles. They are a very important shape as they are completely symmetrical. We call the perimeter the circumference of a circle all the way around. You will need to know these important formulas. So area is pi r squared and circumference is 2 pi r. So we know pi as 3.14 normally. That is the result for pi normally. So, sorry. Here, here O is the center of the circle and R is the radius. The diameter D is twice the radius. That is D equals 2R. So area is pi R squared. So what is the area of the circumference of a circle? So like I said, it would be pi times 4 times 4 because 4 is the radius. So that equals 16 pi. And to one decimal place, this is 50.3 because we know that you can put pi in your calculator or you can calculate as 3.14 to do decimal places. Um, the, the circumference is given by 2 pi r, so this would be 2 times pi times 4, which is 8 pi, and this equals to 20 pi, 5.1 to one decimal place. Again, just to make it clear, pi equals 3. Yeah. Yeah. So there you go. So that's the result for pi. Um, Obviously, I was doing that to two decimal places. Um, so complete the table to know that you need to use your calculator for the value of pi. It is 3.141592654. But there are no pattern to the decimal places. Give your answer here to one decimal place. So the radius, if the diameter is 24, you know that the radius is half the diameter. So the radius would be 12. The circumference is 2 pi r, if I'm not wrong. So it would be 2, 2 times pi times 12. So it would be 24 pi, 24 pi. indeed is. 1 second. So 24 pi is 24 times 3.11592 1 4 1 4 92654 which equals 75.4 to 1 decimal place. And the area is pi r squared. So this will be 12 pi squared. So 12 pi squared. So this will be 12 times 3.141. 92654 squared. Um, sorry, sorry, let me put it out again. So that would be 12 pi squared and 3.1415 2, 6, 5, 4, which, and if we square this, would be 1421.2. So 1, 4, 2, 3. That's what it erases. Sorry, higher squared. It's 452. So if you try that again, actually, I think we did it the wrong way. And it's 3.14. Six, 5, 4. Yeah, so it's 452.4, sorry. So the second one, the diameter is 2 centimeters because the diameter is double the radius, and the circumference will be 2 pi r again. So 2 pi r, which is 2 pi. So 2 times 3.14152.926. Sorry, 92654 equals 6.3. And the radius of pi r squared. So the radius is pi. So it would be pi r squared. So r is 1. Yeah. So it'd be 1 pi, which is 3.1. Yeah. Just to make it clear to you guys, the circumference equals 2 pi r and the area of a circular vehicle pi r squared. So all I'm doing is I'm substituting the numbers into these formulas. So again, for this one, the radius would be 3, as the radius is half the diameter. Circumference would be using the formula 2 pi times, so it would be 6 pi because 2 pi r is 6 pi, as 2 times 3 is 6, so 6 pi would be 6 times 3.1415 equals 18.8, and the area would be pi r squared, so r squared is 3 squared, which is 9, so it would be 9 pi, and 9 pi is equal to 9 times 3 point equals 28.3. 28.3. Yeah. So the last one, again, half of 9 is 4.5, so the circumference would be 2 times 4.5, which is 9. So it'd be 9 pi again, which is 28.3, as we know from the answer before. And the area would be pi r squared, so r squared is 4.5 squared, which equals 20.25 times 3.141 equals 63.6. So these are the final answers. So these are the final answers. Composite shapes. So these are shapes that are made out of several different shapes. Um, So here is an example of a composite shape. We want to calculate its area. There are a number of ways of doing this by dividing the shape into two rectangles and putting a line there. And we know that line equals to 14 as this equals to 14. So the area is now calculated by by 14 times 20 plus 15 times 12 plus 14. So 200. So this is calculated by calculating the area of both rectangles. So we would do 20 times 14, and then we would do 15 times 12 add 14, which is 15 times 26. So this equals 280, which is the area of this, plus 390, which is the area of this. Yeah, that's okay. You can leave, and I will send the recording in the chat later. So this is 280. This is 390. Um, so the answer would be that at that, which equals 670 centimeters squared. And that is that for every perimeter. Let's move on to the next one. Volumes and cubes and cuboids. So finding the volume of shapes is a key application important for many commercial and industrial companies, including efficient packing of items as shown in the picture. Here we will revise volumes of cubes and cuboids and move on to cylinders and other shapes before looking at the surface area. So for a cube of for a cube, all sides of equal length of side length A, the volume is A cubed, and for a cuboid, the side length A with the side lengths of A, B, and C, the volume is A times B times C. So this could also be written as V equals ABC. Uh, Example, show that the cube with the side length of 4 meters at the same volume as the cube length of side of 4 and 2. So again, so the volume of the cube is 4 cubed, which equals 4 to the power of 3, which equals 64. And the area of the cuboid is ABC. Let's assume 8 is A, B is 4, and C is 2. It would be 8 and 4, 8 times 4 equals 64. So the answer equal the same, guys. So the answer of that equals 64 meters cubed, and they have the same value. Find other different cuboids with integers like length sides that also have volume of 64 centimeters cubed. So there are a number of possibilities. 1 times 64, 1 times 2 times 32, 1 times 4 times 16, 1 times 8 times 8, 1 times 2 times 32, and 2 times 2 times 16. These are the possibilities to make a volume of a cuboid equal to 64 meters cubed. So the volume of cylinders are really important shapes that are used extensively for containing food, for example, baked beans, soups, tins of fruits, and many other items. A cylinder is defined by specifying the radius R of the circular cross-section and height H. So its volume is given by the formula pi r squared h. So for example, a typical tin, of baked beans has a radius of 3.7 and a height of 10.8. So this would be, so V would equal to pi 3.7 squared and the height is 10.8. So this equals to pi 3.7 squared equals to 13.69 times 10.8. So this equals to, sorry, yeah, my calculator, 13.69 times 3 it equals 40. So this equals 43.0 times 10.8. This is all to one decimal place, which equals 464.5. So the answer would be 464.5. It should be anyways. Let's see. Yeah. So to the nearest unit, it would be 464. So I can rub that up. All you're doing here is just putting the numbers into the formula, so it shouldn't be too complicated, guys. Like I said, if you got any questions, let me know. We now look at the surface area of cubes and cuboids. So for a cube of side length A, the surface area is made up of six square each the side length A, so the total surface area is 6A squared. Example, what is the surface area of a cube with side length 4? So this would be 6 times 4 squared, which is 6 times 16, which equals to 96, guys. So the answer would be 96 here. So surface area of cuboid. For a cuboid with side lengths A, B, and C, there are six rectangles that to calculate the surface area. These will be in pairs, giving gives the surface area as 2 times A times B plus 2 times B times C plus 2 times C times A. So the surface area is given by 2AB plus 2BC plus 2CA. So what is the surface area of a cuboid with the sides 2, 4, and 6? So this would be 2, this would be 2, 2 times 2 times 4, add 2 and 4 and 6, add 2, which equals to 16, add, add 48, add it's equal to 24. So the answer will be 16 add 48 add 24, which equals to 6, which is 64 plus 28. 88. The answer is 88 for this cuboid. Yes. So as you can see, the answer is 88. The surface area of cylinder of radius r and height h is made up from the top circle plus the side plus the base circle. So the two circles both have a radius, and hence the area is pi r squared because it is a circle. If the curved surface is spread out, it will be a rectangle of the sides h and 2 pi r perimeter of circle. So this gives the total surface area of the cylinder equals to 2 pi r squared plus 2 pi r h. We can also write this as 2 pi of brackets r plus h. So what is the surface area of a tin with a radius of 3.7 and a height of 10.8? So this would be equals to 2 pi 0.7 3.7 and 10.8, which equals to 7.4 and 13.5, which equals to 7.4 times 3.141. 7 point, equals 7.4 times 9, 3.14159, 2, 6, 5, 4 equals to 23.2 times 14.5, which equals uh, 337.1. The nearest square would be 337. So also 337. I think we've done this, guys. This is just repeating the same thing as what we did before. We've done this, or we've just done these. It's repeating the same thing. So we don't need to go through this again. We've just done this. So yeah, congratulations, you've completed this module of area improvement to volume and surface, 2D and 3D shapes and coordinates. Now practice your skills with the activities and test your progress with our knowledge check. Thanks a lot, guys. If you have any questions, please let me know. But other than that, you're free to go.